Welcome back. Let's turn to an example for related rates. Related rates simply mean this. Whenever you have two variables and they're related by an equation, then the rate at which they're changing, that is their derivatives, will also be related. So let me remind ourselves of this calculation we did last time. The volume of a partially filled cylindrical cone, so it's filled up to here, with total height A, radius of R, and filled to height H, was pi A R squared over 3 minus pi, R squared A minus H cubed all over 3A squared. So we'll need that formula in a bit. But for our first example, let's consider the following situation where we're pouring water into a cylindrical cone. Okay, and as it fills, the volume of water will get bigger and the height will get bigger. So we'll write V for the volume of water in there and H for the height to which it's filled. And the point is, obviously V and H are both related. And the first step is to figure out what that relation is. Okay, so in this scenario, again, the total height is A and the radius of the bottom is R. And the important thing to remember is that there's a hidden variable, time, here. So V is not a static thing. It's not just V, but V is really V of t. It's changing as a function of time. And H is also a function of time because as you pour in more water, H will be going up. So people often pretty much never write H of t or V of t, but it's the whole most important part to remember is that they are actually functions of time. All right, so in this scenario, as you pour in water, V and H are related. And the relation is, let's do a specific example here where we have radius 4, or radius 2, and height 4. Okay, so the formula that we had was pi, the thing we called A, which is 4 times the thing that was R squared, so that's 2 squared, all over 3. And then it was pi, the radius squared again, so that was 2 times the total height minus H, so 4 minus H, all over 3. And then we had the total height squared here. So using that previous formula we had up there, we get this. So volume, if we simplify, will be, let's see, that's 16 on the top, 16 pi over 3, minus, and we're going to have a half squared, so that'll be 4 times 3 is 12, so it'll be pi over 12, there was a cube there, times 4 minus H cubed. All right, so that's our formula for how V and H are related. And because V and H are related, their rates will be related. That is, how fast they're changing, and what we really counted as their derivatives. So typically the problem will be asked sort of like this. Given this above scenario, find the relation between, then they'll say the rate of change of V and the rate of change of H. But we know that in shorthand, that's just V prime and H prime. All right? So let's do that first. Well, the trick here is just to take d by dt on both sides of this equation star here. Well, don't forget, V, remember, V is really V of t, and H is really H of t. You have to remember their functions And we're doing the derivatives with respect to t. All right, so the right-hand side is easy. The derivative of v is just v prime. And then we have a constant, so its derivative is 0. And then we have this chain rule problem. So the outside function is t cubed, the cube function. So its derivative is 3 t squared. You plug in the inside, that's 4 minus h. Now I have to take the derivative of the inside. 4 is a constant, no problem. But h, remember, is h of t. So its derivative is just the derivative, h prime. So we end up with the relation is this. V prime is pi over 4 times 4 minus h squared times h prime. All right, the second type of problem that they can ask would go something like this. If, what number did I pick? 5 cubic meters per second. If 5 cubic meters of water were being poured in, how fast is h changing? All right. So first of all, you have to decode the two pieces of information they gave you. The first is this 5 cubic meters being added every second. What that really says is the volume is going up by 5 every second. And so what it's really giving you is the rate of change of v. In other words, it's giving you the derivative of v. So the first thing they told you is v prime is 5. And then the second thing they're asking is how fast is h changing? That's a rate of change. In other words, they're just asking you for what is the derivative. So that's what the question is. And we can easily solve that using this equation up here. We just get, well, let's plug in first. So we'd have 5 is equal to pi over 4, 4 minus h squared times h prime. So that's easy to solve for h prime. We would get 20 divided by pi divided by 4 minus h squared. All right, so that's the answer. Notice it depends on what h is, because as with the cylinder cone, as the water level rate rises, there's less volume and h will be changing more rapidly. So that relates to the third part of how they could ask this. How fast is h changing when h is 1? Well, you just plug in this last bit of data. H prime is equal to 20 all over pi 4 minus 1 squared. So that's 20 all over, let's see, that's 9 pi. And then you have your answer. All right, that's it for our first example with related rates.